Okay, these are the equations I come up for acid base. Remember, H plus and H3O are interchangeable. They're the same thing. So my basic equations are pH equals negative log of H plus, pOH equals negative log of OH. Really, it's like if you just remember three of them, you get all of them. H plus equals 10 to the negative pH. OH equals 10 to the negative pOH. H plus times OH equals 1 times 10 to the negative 14th. That's your kW. And pH plus pOH equals 14. That equals your pKW. Okay. So with these equations, I can create a pH map. And this might help you when you do calculations. So I can get from the concentration of well, let's start off with pH. I can get from my pH to my pOH back and forth. I can get back and forth by knowing that pH plus pOH equals 14. So to go in this direction, pOH equals pH minus 14. To get to this direction, pH equals pOH minus 14. And that's just algebra. Okay, something called algebra. If I want to go backwards, if I want to go from down here and find my H plus, or down here and find my OH, this will start looking like a square box. So to get to your H plus, you would say H plus equals 10 to the negative pH, this equation. Okay, to get to this equation going down, I'd say that OH equals hydroxide equals 10 to the negative pOH. Okay, to go backwards, to go back up, we go to our basic pH equation. pH equals negative log of my H plus. Okay, to get back up, I would say that pOH equals negative log of my hydroxide. Okay, and then I can go back and forth between these two because I know this equation. I know that H plus times my OH equals 1 times 10 to the negative 14th. Okay, so if I'm going in this direction, hydroxide equals, okay, and that's equal to your kW. So you could say kW over H, or just 1 times 10 to the negative 14th divided by my my OH concentration. Nope, that would be my H concentration. And going the other direction, that H plus would equal 1 times 10 to the negative 14th divided by your OH concentration. So this little map will take you through everything. So given, if I tell you that you got 2.5 times 10 to the negative 5th molar HCl, I want you to find the concentration of H, the concentration of hydroxide, the pH, and my pOH. Okay, so anytime you know one, you know all four of these. Getting busy. Okay. First of all, this is a strong acid. And strong acids dissociate 100%. So it's going to dissociate to H plus Cl. So whatever the concentration HCl is, that's your concentration of H. And it only gives off one H. Okay, so even if you have like sulfuric acid, only one H dissociates. And that came from our ions in aqueous solutions lab. So the H plus for this is going to equal the same, 2.5 times 10 to the negative fifth molar H plus. That's for a strong acid. Okay, so now it gets pretty easy. Okay, I want to do the pH. It's a negative log of 2.5 times 10 to the negative fifth. So I take my calculator, and it's just learning how to use your calculator, which we already know how to do. You plug in the negative, okay, you hit log, it puts in a parenthesis automatic, you put in your number, 2.5 times 10 to the fifth is second EE, negative 5, close bracket. The answer is 4 point. Now, here's where it gets interesting. The 4 is your insignificant zeros. I had 2 sig figs here, so I need 2 more numbers to give me the right number of sig figs. And the next 2 numbers are 60. So 4.60 is my pH. Now, easy to find the pOH to go from here to here. pOH equals pH minus 14. So it's going to equal 14 minus 4.60. So 4.60 is 9.4. So the pH is 4.6, the pOH is 9.4. You add these two numbers, it equals 14. Now, let's go down here and find the H plus. The H plus, well, we started knowing the H plus. The last thing I have to know is the OH. So the H plus started with that's where we started here. I went 2.5 times 10 to the negative fifth. I took the pH, the negative log of H. I found out that this number equals 4.60. Subtracted from 14. 14 minus that equaled 9.40. Now let's go down to here. I can say that my OH is equal to 10 to the negative pOH. So on a calculator, second log is inverse log, then I hit negative 9.40, and there's my number, 3.98. Now I'm going to round that number because this is just 2 sig figs. That's my number zeros. So I'm going to round 3.98 to 4.0 times 10 to the negative 10th. Now this number has a unit. It's molarity. This number was molarity. pHs don't have units. Now there's another way I could have gotten the OH. I could say that the OH is 1 times 10 to the negative 14th divided by my H plus, 2.5 times 10 to the negative 5th. So I'll do that same number. 1, second EE, negative 14. And I'm going to divide that by 2.5 EE to the negative 5th. And I get the same number, 4.0 times 10 to the negative 10th molar. So if it doesn't matter if I got it from here and here, I got the same number in both cases, 4 times 10 to the negative 10th. And that's how you do pH-pOH calculations, which I'll expect you to do. I'll give you a few examples. If I told you that you had 2.5 times 10 to the negative 5th molar, now if I said that was barium hydroxide, that's different. In acids, like sulfuric acid that has 2 H's, only one of the H's dissociates. So it comes off as just H plus HSO4. So with acids, the number of H's doesn't matter. That's what we said on the lab. The number of H's doesn't matter on your acid strength. But not so for bases. Barium hydroxide will dissociate to Ba plus 2, and this is one way, just like a strong acid, it's one way, plus 2 hydroxides. So if I say that I have 2.5 times 10 to the negative fifth, now I'm going to change this to mole per liter. So if I want to know the hydroxide, I would say for every 1 mole per liter, or for every 1 mole of BaOH2, there's 2 moles of hydroxide. So this would become 5.0 times 10 to the negative fifth hydroxide. Now that's unique to bases. Bases, the exponent, the subscript does matter, but not in acids. So that's because you get 2 for every one of these barium hydroxides. You get 2 OHs when it dissolves in water. Okay. If I told you you had 2.7 times 10, let me use a different number. I'm getting very similar numbers. 5.62 times 10 to the negative fourth molar sodium hydroxide. Okay, that's 1 to 1, so you would have 5.62 times 10 to the negative fourth molar hydroxide. So this is the salt, NaOH, and it would just release 1 hydroxide. Now that's my starting point on the mole map. Okay. I'm going to first, the easiest thing for me to find will be the pOH. So the pOH is negative log, I write down my equation, of hydroxide. So it's the negative log of 5.62 times 10 to the negative fourth, and we'll see what that equals. Negative log of 5.62 EE negative fourth. That equals 3 point. Now the 3 is not significant on the pH scale. So the pH equals 3. That's my number of zeros. Okay. If I write this number down, 0.123562, that 3 is these 3 zeros right there. You can view that as the 3 insignificant zeros. Here comes your sig figs, and I need 3 of them. So it's 250. Okay. You have your pOH. Finding your pH is easy. It's 14 minus 3.250. I'll do a little secret here, I'll tell you, honestly. Instead of me going 14 minus that, I just go minus 14, and I'll show you why in a second. This number comes out to be positive, and I know it's negative there, but it comes out to be positive 10.750. Now that's my pH. Okay, and I got 3 sig figs. These the 10 doesn't count for sig figs. My sig figs are 1, 2, 3. Okay, now here comes my trick. My H plus is 10 to the negative pH. So 10 to the negative 10.750. So me putting that in backwards, you see the negatives already there. That's my trick. I'll leave that number in the calculator. Okay, 7 second anti-log, and then I'm going to put in the answer, second answer. Easier than redoing all your numbers. You get 1.78 times 10 to the negative 11th molar. That's your concentration of H plus. Now, if I take that and multiply it by that, let's try that, times 5.62 to the negative fourth, I get the kW, 1 times 10 to the negative 14th. So I also could have found that number by taking this to find H plus as an alternate, because it's all circular. I could have taken 1 times 10 to the negative 14th molar and divided it by, that's not molar, it's just concentration, 1.78 times 10 to the negative 11th. Yeah, just did that wrong. 5.62 times 10 to the negative fourth would have equaled 1.78 times 10 to the negative 11th. So there's two ways I can get there. I can get there from my pH, or I can get there from my H+. It's all circular. All right, and that is how you do pHs and pOHs.